All right, we are looking at Focus Standard 4, Learning Target A. I can identify key features of a linear function. So we've got a contextual situation happening here, and it says that we're going to be writing an equation that represents the number of tickets sold, y, that's dependent on the price of tickets, x. So there's some important information here just in the question before I even read this. It says that I'm going to be thinking about my tickets sold are going to be y, so I'm going to start by making a key. And I'm going to say my y is going to be called the number of tickets sold. So I recommend when you're working through context that you slow yourself down and just work through diligently with everything you see and don't be trying to rush. X is going to be labeled as the price of ticket. As we're making an equation, we're knowing that we're going to be using those two placeholders. Okay? A carnival business is trying to determine the price to sell tickets for. So, any kind of business, they've got to set a price, and if they set it too high, nobody's going to show up. And if they set it too low, a whole bunch of people are going to show up and they might not make any money because they made it too low. They determine that if they set the price at $1.50 for each ticket, they will sell 100 tickets that day. That statement right there is a coordinate pair. So I'm going to start to be creating a table here. Now, if X is standing for price and Y is standing for sold tickets, then I know that if I set the price for $1.50, then I will sell 100 tickets. Okay? If they set the price at 50 cents, they will sell 300 tickets. There's another coordinate pair. So there's 0, 50, there is 300. Okay? I've got to write an equation. So all I've done right now is I've taken my context and I've modeled it mathematically using a table. I have not answered the question, but I'm really close to answering the question at this point. I've got my model. Here's my table. I've got my key, so I'm understanding what I'm doing and I'm making sure my X and Y is going in the right place. And I know now that I've got my table that my two key features I'm looking for is change of Y over change of X, and I'm going to be looking for the y-intercept. First thing that I can find here is change of Y over change of X. I'm going from 300 to 100, so I'm reducing by 200 there. Every time that this is increasing by $1. So I'm losing 200 tickets being sold for every time I increase my sale price for $1. Okay? Bring this back, I need to go from 50 cents back to 0 to get to the y-intercept, so I need to go back a half. So that means to keep this proportionally the same, I'm going to be going back only 100, right? Because negative 100 over 0.5 is the same rate, or the same rate here as negative 200 over 1. I can proportionally scale that up and they would be the same number. So 300, plus 100 is going to give us a y-intercept of 400. This coordinate pair here means that if they are free, 400 people will show up to ride the carnival games, or the carnival, whatever they are. All right, so putting this into an equation, I've got my key features. There we go. And there we go. Those are the two pieces we're going to see in the equation. So we've got y equals, also f of x equals 400 for the y-intercept, minus 200x. I start with 400 tickets, and I lose 200 tickets every time I increase the price of the ticket by $1. Okay? Identify the key features. Well, we already did that in the process. We already did this identification. Now, what we want to do when we're in context is not just identify them, but also state them in context. Okay? So I might say y-intercept is 0, 400. That's identifying it in math. Now let's identify it in context. And so what we would say is when it's free, or when tickets are free, 400 people will show up. Will ride the rides. something like that. Okay? Rate of change of y over change of x. So you're going to identify it using math. And then you're going to restate it using context. So you're going to be saying, I lose 200 tickets, or ticket sales. I lose 200 ticket sales every time I increase cost by $1. Every time I increase by $1, I lose 200 ticket sales. Okay? Let's look at number 2. So number 2, we all did fairly well on our tests with this one. This is definitely a much easier question than number 1, so I'm going to go through this pretty quick. So Mary runs a computer business. She charges a flat rate fee of $50. Right there, that's our y-intercept, identifying that as 0.50 because it's a flat rate fee, and $25 per hour, so that's looking like 25 over 1 for the rate of change of y over change of x. And so we're going to make that equation, and it's saying use c for cost and h for hours. So this is cost as a function of the number of hours is equal to 50 plus 25h. And I'm just going to go ahead and move on from that point because I feel like we were all at that and we all did very well on that one. It was this first one that we struggled with mostly. Much more work going on there. So you're going to go to the on your owns and you're going to be completing that, turning it in to the basket. I will check it and sign you up for a retest. Good job and keep up the good work, guys.